All right, this is part 3 of module 7. We are going to be starting with the topic graphing a cubic function in the form y equals ax to the third. Um, the easiest way to do this is to get a graphing calculator. The graphing calculator apps on your phone work great for this. The TI Smart View, I put a whole bunch of links up on Google Classroom with software that you can get, apps you can get for your iPhone that will do all of this. So what we're going to do is we're going to go into y equals, and we are going to, in y1, we are going to enter in y equals negative 5/4 x to the third. Now we do this by clicking the negative button here. It's very important that you do the negative button and not the subtraction button. So negative 5/4. Now we enter 5/4 by doing 5 divided by 4. And then we hit the X button and we raise it to the third power. Okay, so this should look like this, right? And we're going to look at the table of values. So we do that by hitting second graph, and we have our table of values here. I recommend hitting up and down on the X so 0 is right in the middle, because if you look at the directions, they want X being 0, they want 2 positive X values and 2 negative X values for the 5 points. So we have that right here. X is 0, we're looking at 0, 0. Then we can go to 1. 1 is negative 1.25. So negative 1.25. So 1 negative 1.25. So that's 1, and then 0.25 is just a little more than that. On Alex, you can actually type in the coordinate points that you want to graph, and then 2, negative 10. I don't even know if I have 10. 1, 2, 3, 4, 5, 7, 8, 9, 10. I'll come down here with it. Okay. And then they want 2 negative X values. So we're going to use negative 1, positive 1.25. So negative 1, positive 1.25. And then negative 2, positive 10. So we're going to go to negative 2, positive 1, 2, 4, 5, 6, 7, 8, 9, 10. And then if we look at the graph, if we hit graph, and as you can see, I can't see my graph when I hit graph. If that happens, hit zoom and then 6. And when you hit zoom 6, it puts the X and the Y coordinates right in the middle, and we're looking at a shape like this. On Alex, you could just hit graph the lines or whatever it says to hit that button to actually graph it. Okay. So we're going to connect our dots with a squiggle. That is what a cubic function would look like. Okay, then we are moving on to the next problem. Same technique. We are going to enter in the equation into our graphing calculator. So once again, I hit y equals. I can clear out what I have, or you can keep it and just write over it. Either way, I'm going to do negative, not the subtraction button, but the negative button down by the decimal point underneath the 3. 1 divided by 2, or you can use negative 0.5 if you want, x to the third. We're going to hit second graph to get our table of values, and we want the x value being 0. We want 2 positive and 2 negative x values. So we have that in our table. So that would be the point 0, 0. Then 1 negative 0.5. And then 2 negative 4. 1, 2, 3, 4. And then negative 1, positive 0.5. And negative 2, 1, 2, 3, 4. Okay. And we could hit graph to see what that's going to look like. And we have our squiggle like that. So you see these squiggle shapes, that's what all cubic functions are going to look like. You're always going to have the use of a graphing calculator app, looking at the table of values. We're not going to have to draw these by hand or anything without using our table of values. Okay, let's move on to our next topic. Our next topic is classify the graph of a function. There's a lot of functions here that you already know what they look like, but we have some options of what they want us to choose from. They want us to say, is it a vertical line, a horizontal line, a line with negative slope, a line with positive slope, a parabola opening up, or sorry, parabola opening down, or a parabola opening up. Let's talk about what each of those mean. So a vertical line, we already know a vertical line. A vertical line is x equaling a number. So for example, like x equals 2 would be a vertical line at 2. I 1, 2, it would be a vertical line because every x value on this line has a coordinate point of 2. A horizontal line. A horizontal line would be y equals a number. Or in this case, because we are talking about function notation, it would be like f of x equals a number. So if we had f of x or h of x or g of x, something like that, equaling -3, that would be a horizontal line at 1, 2, 3, -3. Okay, a line with negative slope, we're talking about linear here, right? Line with negative slope. So we are looking at something like f of x equals -mx plus b, that m being negative. So f of x equals -1/2 x plus 3. Okay, remember starting at 3, going down 1, right 2, and we have our negative line like that. And then we have line with positive slope. Same thing, we have f of x equals a positive mx plus b. So for example, we don't have to use f of x, we can say g of x equals 3x minus 1. That 3 being positive, that slope being positive means that we're going to have positive slope. We knew that already, right? So we go up 1, 2, 3, and we have our line with positive slope. Our new things are parabola opening down and a parabola opening up. What makes a parabola? That's going to be a quadratic, an x squared. All right. So a parabola is from a quadratic. We are looking at something like f of x equals x squared. Okay, when we have an x squared term, it's a parabola. If we have a positive number in front of x squared, our parabola is going to open up. If we have a negative number in front of x squared, our parabola is going to open down. Okay, you might remember this from Algebra 2. So a positive number here, such as g of x equals 3x squared minus 9x plus 2. Because there's a positive 3 in front of the x squared, our parabola is going to open up. If we had h of x equals -1/2 x squared plus 7x minus 3, okay, that -1/2 x squared is going to make our parabola go down, that -1/2 in front of that x squared. Okay, so now let's go back to our exercise here. So this first k of x equals -3x squared plus x plus 2. That x squared we're going to be talking about our parabola, okay? There's a negative in front of it, so it's going to be a parabola opening down. We'll check that box off. Here we have h of x equals -2. That would be the same thing as y equals -2. So y equals is a horizontal line. Then g of x equals 2x plus 4. That's mx plus b. We have positive slope here. We have a positive m. So it's a line with positive slope. And then I added 3 more to this. F of x equals -3x minus 3. There's that mx plus b again, but we have a negative slope. So that would be a line with negative slope. Then g of x equals 4x squared plus 1. That x squared means it's going to be a parabola. There's a positive number in front of the x squared. That's going to be a parabola opening up. And then x equals 5. That would be a vertical line. And with that topic, all you have to do is choose what one it is. Should be pretty easy to do. That parabola opening up or down should be the new thing for you. But it's pretty easy. If you see an x squared, look at the number in front of that x squared, and that'll tell you if it opens up or down. Okay. If another option, what you can do is you can plug these into a graphing calculator under y equals, but you're going to run into an option with something with x equals. The graphing calculator cannot do something that starts with an x equals. All of the g of x, f of x, h of x, k of x can be switched to y, and you can enter them in that way. Okay. Down to our next problem, our next topic. We have evaluating a rational functions, problem type 1 and 2. These are pretty easy, and it looks like a majority of you already have them done. We are evaluating rational functions. I just combined problem type 1 and 2. This is problem type 1, that's problem type 2. We want to find g of -3. So what we're going to do is we're going to plug -3 into that everywhere we see an x. So -3 minus 4 over -3 plus 7. -3 minus 4 is -7. -3 plus 7 is 4. So our answer would be -7/4. Okay. Same thing here. Find f of 6. We're going to make this 6 minus 12 over 3 times 6 minus 18. That is going to lead us to -6 over 18 minus 18. 18 minus 18 is 0. Okay. Now, what happens when I have my denominator being 0? That means that my answer is going to be undefined. Okay. Remember, you cannot divide by 0. If you have a 0 in your denominator, that's when you write undefined. A 0 in your numerator is okay, but a 0 in the denominator is undefined. Okay, just remember that. We're actually going to talk about that in a couple topics. Okay. Here we have some more examples of those problem types 1 and 2. We have a little more complicated of a rational equation here. So we're going to enter in -3 to that. So we have -3 squared minus 4 times -3 minus 32 all over -3 squared minus 4. Now it's very important that you follow your order of operations here, and we have to do our exponents first. So -3 squared. Remember, a negative squared is a positive, so that's going to be 9. Now, -4 times -3 is positive 12 minus 32. And then -3 squared is 9, and we have 9 minus 4. So 9 plus 12 is 21. And 21 minus 32 is -11. And 9 minus 4 is 5. Negative 11 over 5 can't be simplified, so our answer is negative 11 fifths. Last problem, h of x. We want to find h of negative 4. So we have negative 4 minus 2 over negative 4 squared plus 2 times negative 4 minus 35. So negative 4 minus 2 is negative 6. Negative 4 squared is positive 16. 2 times negative 4 is negative 8 minus 35. So negative 6 over 16 minus 8 is 8. Then 8 minus 35 is negative 27. So we have negative 6 over negative 27. Well, they're both negative, so it's a negative over a negative. It's going to be a positive. And can we simplify 6 over 27? Yes, we can. 3 goes into each of them. So 3 goes into 6 2 times, and then 3 goes into 27 9 times. So our answer would be positive 2/9. Make sure you are simplifying your answers at the end. Okay. Our last topic of module 7, we have state values of x that are not in the domain of f. So we're talking about excluded values. We did this a lot in module 6. So we're just doing it again. Excluded values, values of x that make the denominator 0. When we're looking for excluded values, we're only looking at the denominator. We're not looking at the numerator. So we want to figure out, when does x squared minus 9 equal 0? We have to factor it. X squared minus 9 becomes x plus 3 times x minus 3 equals 0. And if we apply the zero product property, like we've done so many times before, we have x equals negative 3 and x equals 3. So when x equals negative 3 and x equals positive 3, that makes the denominator 0, which leads to an undefined answer. So in conclusion, x cannot equal negative 3 and 3. So those would be our excluded values. Over here, we have f of x equals x plus 9 over x squared plus 18x plus 81. Same thing, we're only going to be looking at the denominator of x squared plus 18x plus 81. And we're going to set that equal to 0, factor it. So we're looking for two numbers that multiply to 81 and add to 18. And that would be 9 and 9. So we have x plus 9 times x plus 9. So x plus 9 equals 0 and x plus 9 equals 0. So we get negative 9 and negative 9. Now, obviously, we don't have to write the same number twice. So we can just say that x cannot equal negative 9 for our excluded values. Okay? If you have any questions on Module 7, please let me know. I'm available 9 to 1 every day, or send me an email and I'll get back to you when I have the chance. But remember, Module 7 is due Friday night at 11:59. Okay? Good luck.